Hello everyone, I am Chandrahas Misra. In this lecture, I am going to discuss representation of graph. In this lecture, we will discuss adjacency matrix, incidence matrix, and adjacency list. So we'll discuss how can we use adjacency matrix to represent a graph. We'll also see incidence matrix and then adjacency list to represent a graph. Let us begin with adjacency matrix. So here we have one graph, very simple graph. In this graph, we have three nodes like this. This is undirected graph. So just numbered it as 1, 0, 1, and 2. Okay. So here we can see this graph is having three nodes, that 0, 1, and 2, and a connection from 0 to 1, 1 to 2, and 0 to 2. So if we want to represent this graph using adjacency matrix, so we'll have to identify number of vertex in this graph. So here three vertex. So the size of the matrix will be 3 cross 3. So we'll create one matrix. So this is the matrix. Here we have 3 rows and 3 columns. 3 rows. Okay. So numbered as 1, 0, 1, and 2, 0, 1, and 2. So how to fill up this matrix? We have to see whether there is an edge from 0 to 0, 0 to 1, 0 to 2 or not. If there is an edge from 0 to any vertex, then we will put 1 at that place. So basically, if this is the ADJ matrix, if we are calling it as ADJ, so in this ADJ, IJ at the IJ location will put 0 if there is an edge from I to J, and we'll put 1 if there is an edge from I to J. We'll put 0 if there is no edge from no edge between I and J. Simple formula for this. So let's begin with the graph. Here we have one edge from 0 to 1. So we'll put 1 here. In the next year, we have 0 to 2 also. So we'll put 1 here. In the next row, we have 1 as the vertex. So whether there is an edge from 1 to 0, yes, there is edge between 0 and 1. So we'll put 1 here. 1 to 1 noise, so we'll left it blank. From 1 to 2, there is 1 to 2, there is an edge, so we'll put 1 here. 2 to 0, yes, this is the edge, so we'll put 1. 2 to 1, 2 and 1, yes, 1 is. 2 and 2, no is. So this is our adjacency matrix for this graph. Suppose this is undirected graph. Basically, we are not having any direction on the edges. So this is undirected graph. What about if we have directed graph? Suppose this is the graph. And numbered as 0, 1, 2, and 3. Here we have some edges like 0 to 1, 0 to 2, 0 to 3 to 0, 2 to 3, like this. And now we want to make the adjacency matrix for this graph. So here we have 4 vertex, so we'll need 4 cross 4, 4 cross 4 matrix. Okay, so let's begin with this. We'll create So let's create one matrix with 4 rows and 4 columns. So this is the matrix. Matrix. Here we have 4 rows and 4 columns. So let's number it as 0, 1, 2, 3, and column also 0, 1, 2, and 3. So what we'll do, we'll just see whether there is an edge from 0 to other vertices or not. So if there is an edge from 0 to 1, 0 to 2, 0 to 3, we will put simply 1. If there is no edge, we'll put 0. Okay. So here you can see in the graph 0 to 1 there is one edge, so we'll put 0 to 1 as 1. If there is an edge from 0 to 2, yes, we'll put 1 here, we'll put 1. If there is an edge from 0 to 3, 0 to 3, no edge. So if the edge from 3 to 0, it is not considered as the edge from 0 to 3, because this is directed. Okay? So we'll not put here anything. Now come to vertex 1. Is there any path from 1 to 0 or any other vertex? No. So we'll not put anything. Is there any else from 2 to 0? 2 to 0? No. 2 to 2, is there any path? No. No path. 2 to 3? Yes. Here we have one edge from 2 to 3. So we'll put 1 at this place. 3 to 0? Yes, we have one. Yes, you can see here. We have 3 to 0. Okay. So now 3 to 0, we have only one edge, so we'll put 1 here. Is there any other vertex that is left? No. So you can see here, we have 4, only we have 4, 1, because here we have 4 edges. Because here we have only 4 edges, this, and this. So like this, we can use adjacency matrix for the for any graph. Okay. Now, if you want to create uh, adjacency matrix is done. How can we create an incidence matrix? It is also a way to represent the graph. Let's begin with an example, and we'll see how can we create incidence matrix. So let's have a graph like this. This is the graph with 4 vertices. This is a graph with 4 vertices. Okay. Let it numbered as 0, 1, 2, and 3. Okay. So suppose edges are like this. We have some edges. Okay. Now suppose one edge is also from. Now all these edges are labeled edges. It means we have labeling as E1, E2, E3, E4, and E5. So here we have 5 edges, and these edges are labeled as E1, E2, E3, E4, and E5. So what we'll do, we'll create one matrix. And what will the size of matrix? This will be V cross E. It means V is the number of vertex and E is the number of edges. So here we have 4 vertex and 5 edges, so this will have 4 cross 5. Okay, so let's begin with the matrix. We'll create one matrix with 4 rows and 5 columns. This is the matrix. Here we have 4 rows. We are having 5 columns. 0, 1, 2, and 3. Now what we will do, we will just write the is label here in the column, like E1, E2, E3, E4, and E5. So if there is any edge that is directly connected to the vertex, we'll put at 1. At that place 1. If there is no connection, we'll not put anything. So simply take first vertex 0. So is E1 connected directly? Yes. So just put 1. Is E2 connected? No. Is E3 connected? No. Is E4 connected directly? Yes. 4 is connected. Is E5 directly connected? No. Simply come to this 1, E1. Is E1 is connected to 1? Yes, put 1. Is E2 is connected with 1? Yes, put 1. Is E3 is connected to 1? No. E4 is connected to 1? No. E5 is connected to 1? Yes, put 1 here. Now come to vertex 2. So is E1 is connected with 2? Is E1 is connected? E1 is this is E1 is connected with 2? No. So will not put anything. Is E2 is connected with 2? E2 is connected with 2? Yes. So we'll put 1 here. Is E3 is connected with 2? Yes. Is E4 is connected with 2? No. Is E5 is connected with 2? No. So we'll let it blank. So is E1 is connected with 3? No. Is E2 is connected with 3? No. Is E3 is connected with vertex 3? Yes. Is E4 is connected with vertex? Yes. Is E5 is connected with vertex? Yes. Now what we'll do, all blank cells will be filled by 0. Okay. So now this is the incidence matrix. You can see it. Okay. So like this we can represent. Now move to the next way, that is adjacency list. Okay. So how can we use adjacency list to represent a graph? So here we have an you can say an array of list that contains the list of all adjacent vertex of a particular node. So we'll see with the example. Suppose this is the graph. Here we have 4 vertex. Suppose the vertices are connected like this. Okay. Vertices are 0, 1, 2, and 3. So what we'll do here, we will create a list of adjacent vertex to each vertex. Okay, so here we have 4 vertex, so there will be 4 different lists for each vertex, and we'll store this in the array. Suppose if we take 0, so what are the vertices that are adjacent to 0? So like 1 and 3. So here we have a node in the linked list that is 1. Another one is 3. And this is not. Now come to 1. So what are the adjacent vertices of this 1 vertex? So we can see 0 is directly connected to adjacent vertex, means the vertex which is directly connected to a vertex. So 1 to 0, yes. 0 is adjacent, 3 is also adjacent, and 2 is also adjacent. So at 1 we have 3 nodes, that is 0, 2, and 3. This is the last one, so we will have null. Now come to vertex 2. What are the edges connected to 2? Only one edge, that is 1. So only one is adjacent to this two vertex. So we'll have one node in this list. Only one node in this. Now come to 3. So 3 is having two adjacent vertex, that is 0 and 1. So we'll have two node in this list. So we'll have 0 and then we have 1 and then null. So basically these here we have four different lists, and these lists are containing vertices at the adjacent vertices as the node. Okay, and now this is the array which is having the address of the list starting start. So here in this array, each index is having the address of the list containing adjacent vertices, or we can say adjacent nodes. So we can see uh, 0 at the 0 index. 0 is the vertex, and it is having the address of the list which contains 1 and 3, where 1 and 3 is the adjacent vertex of 0. Similarly, at index 1, we have address of the linked list containing 0, 2, and 3. At index 2, we have address of the list which contain only one node, that is 1. And at index 3, we have the address of the list containing 0 and 1. So like this, we can create adjacency list for the for any graph, and it is very useful for performing multiple operations, various operations on graph, and it is also efficient to use this. So thank you for listening. Following are the references that we have used in our lecture. Disclaimer. Thank you.